Hey, what's up, Pre-Cal 12? You're at home right now, either sleeping in or you're late to class. But regardless, I got a podcast for you. Thanks to Rosemary helping us out. We are going to go through the podcast on section 4.2b, and it just so happens to be one of the toughest ones, so let's get started. So here's the thing. I want to go behind the scenes really fast with you. And I put so much emphasis on this and have had problems with this in the past with students comprehending this, that I'm actually going to stick this up on the board somewhere, okay? So what I'm going to do is I'll take this like a huge sticky note and I'll put it somewhere. But this right here is extremely, extremely important for you understanding what we do over here, okay? In fact, if I would venture to say, if you get this, over here is going to make it a lot easier, okay? So let's go through the why before we go in through what we're actually doing, okay? All right, so with that being said, take out, like, if you have a note sheet. Some of you like to write on the back. Some of you might want to go get notes in the back corner, for those of you that choose to do that. And let's get started on kind of where we're headed, okay? All right, real quick. Let's kind of recap here. We have this idea of coterminal. What did coterminal mean? What were we referring to with coterminal? I like that. Same terminal angle, what is terminal again? Just a heads up as a refresher. Jake? Yeah, the ending. And we say that we have the other side of the angle, which we call the, good Audrey, and when it's at 0 degrees, we call it what?
Standard position.
Standard position. Very good. So that's where we're headed, okay? Trying to think of any other definitions that I really wanted to get to. Well, yeah, I did want to get through this. When we talk about the ratios, right? We have this acrostic that helps us with the ratios of a trig expression. What do we call that acrostic? Good, Bianca. And we also had this thing, if you remembered, we divided it in two, where the unit circle kind of represented our sine, cosine, tangent, cosecant, secant, and cotangent. And we remembered that what related with sine, cosine, and tangent? Can someone give me those that relates to the unit circle, Caitlin?
Cosecant is with sine, secant is with cosine, and then cotangent is with tangent.
Yeah, so cosecant and sine are the same, right? Secant and cosine are the same, and cotangent and tangent, and they're not the same. What are they? What do I mean by that? They go together, and it's the reciprocal. That the signs stay the same. The only difference is it's the reciprocal. Did I do the flip in class? Did I do that with y'all?
No.
I might have to do it later. I don't have a lot of energy. I think it was the other two classes, they weren't getting it. So I actually, I flipped a little bit. It was a little weird, but we're good. But these go together, right? And when we talk about sine, what is sine related to on the unit circle? The y. There you are. Cosine is x, and tangent is y over x, and we remember this, right? Now, we're getting into what we're going to do today. And this is really where we're kind of building off this concept. And this is, I think, completely new. Now, question. Have y'all ever seen these definitions? Yeah, figured as much. This is probably the first new thing that you're going to learn from Algebra 3 to Pre-Cal 12, okay? These are called even and odd trig functions, okay? I would get these 6 down. Even and odd trig functions. And I'm going to show you why they are what they are, okay? So, question, real quick. Big concept. What was our acrostic for when things are positive? Good. Y'all remember the second acrostic, if you forget that one. Did I give you this one? Someone said in the other class, all short teachers care. Did I give you that one? Which is really, really rude and did not appreciate that. But if it works, then it works, okay? How many of you don't understand, and I want to be honest here, we're going to be a little vulnerable here. How many of you don't understand what that represents? Perfect, that's fair, I love that. Because here, I will tell you this, if you don't understand why this is why this is what it is going to be very hard for you, okay? So let's go into that just a little bit. What does the A represent? All, good. What does the all represent? Yeah, everything is positive. If you think about it, remember, the x is positive and the y is positive over here on the first quadrant, right? What about the second quadrant? Sine, good. So we remember sine is positive over here, and we remember that the x is negative, but the y is positive. Someone link these two together. Why would sine be positive if the x is negative and the y is positive?
Find the up above the x-axis.
Perfect. We just linked that, didn't we? We just said sine was related to y. Therefore, if y is positive, therefore sine is positive. Right? If you're good, say uh-huh. We're tired today? I hear you. It's Monday, right? Keep rolling. You're good. So the y would be positive here. And that's why sine's positive. What about tangent? Why is that positive? I thought both of these are negative. Bingo. Yeah, they cancel out, right? When it's a y over x and they're both negative, we know that it would be a positive. That's why the third quadrant is positive. What about the fourth one?
X is positive, y is negative.
Exactly. And that should make sense, right? Because cosine is related to x and therefore it will be positive. All right? Are there any questions on that? All right, here's the good stuff. You ready? All right, I don't know if I've ever taught it like this, so we're going to try something a little new, okay? We're going to take an angle, all right? We're going to take a positive angle. We're going to represent this angle as t, okay? As t. Now remember that we have these definitions, right? And what I would like to do is just take this first definition of cosine of t is equal to cosine of negative t, okay? Now t could be any angle, right? It could be any angle whatsoever, all right? What we're going to do, though, is we're going to say that t, in this context, is equal to 30 degrees, okay? So we're going to say, what is cosine by plugging it in? Do y'all see that? I'm just showing you why this is true. What is cosine of 30 degrees? Someone throw that on their unit circle as you check that out. What is cosine of 30?
Square root 3 over 2.
Square root of 3 over 2. Good. Okay, money. Now, what would be the right side when I plug in? Good. Cosine of negative 30. Nice. And what is cosine of negative? First of all, where is negative 30 going to be? What quadrant? The fourth, right? Question. If this up here is square root of 3 over 2, and I go down to negative 30 degrees, what would that be? It would actually be, it's a good thought, Devin, it'd actually be the same thing. It'd actually be the same thing. Look real quick at 330 degrees. If you go backwards at negative 30 degrees to 330, what do you see as the cosine of that value?
Root 3 over 2.
Root 3 over 2, right? Why is it not negative?
It's the x is still positive. It's on the same side.
Bingo. Look, all's positive up here, but what else is positive?
Cosine.
Cosine. You see that? Okay? I'm going to take one from down here real quick. Okay? Do the same thing. I'm going to do it in the gray spot here. And I think, I have it. Or there it is. So I'm going to put right here, just do the sign real quick. Okay? And I know, by the way, this is not extremely exciting. We're going to get to the problems, but I got to get you the y first. Okay? As I look at sine of 30, okay? And I'm going to set that equal to sine of negative 30, okay? I'm literally taking this definition and just putting it down here, okay? So what is sine of 30 degrees? Just throw that, what do you see there? 1/2, right? Good. And what is sine of negative 30? Negative 1/2, good. Are those equal to each other? No, they're not. That is why when we do the bottom ones, you see that negative sign there, right in here? That negative sign has to be on the outside for sine, tangent, and then obviously cosecant and cotangent. Got me? So why is that the case? Well, sine is negative down here, right? You got me? Where it's positive up here. So that's why in the definition, you've got to include a negative within that in order to make it a positive. All right? Now, real quick, question, do y'all understand that? Does that make sense? Yeah? Caitlin.
So there would be a negative sign and it's negative 30, or it's just negative sine of 30?
So we would say that in this instance, the sine of t, which was 30 degrees, could be any angle, is equal to the negative sine of negative t. What that means is, if I took out that negative and kept it as the same definition, it doesn't work with what I have in red. I just need you to see that, okay? Just need you to see it. All right. Any other questions on that? Okay, so just real quick, you'll need to know this. The top two, secant and cosine, we call these definitions are linked together. What's in red, where it reflects over here on this side, we call that even symmetry. Okay? All right, that's even. Whereas the other two, really the other four, are what we call odd. Okay? Where you have to have the negative, that would be odd. Where you don't, that is the negative, or the even side. Okay? The even side. All right, so with that being said, we're going to look at something here. We're going to go into a couple of these and just make sure that we're all good. Now, when we go from here, I'm going to kind of use this, just kind of put this now, and that way we can see it, at least refer to it. Okay? All right, here's what I'd like for you to do. On a separate one, I want you to create this chart right here. Okay? All right, we're going to say that sine of t is equal to 4/5. Really, what we're going to find here is that 4/5 will be the answer every time. The question is whether it is positive or negative. Okay? Whether it's positive or negative. So let's do this real quick. Let's represent t as just some angle. Okay? All right, so let's do this. T's here. Jake, question. If I took pi and subtracted t, what quadrant would it be in? Let me do this. Maybe this will help. That was a weird question. If I took pi, where would I start? Yeah, so we would start right here, right? If I subtracted t, where would I go? Do we know what t is? We don't, right? Right now, what I'm saying is that t is some angle in the first quadrant, right? So if I took pi and subtracted t, what quadrant would it be in? Second. Perfect. Does that make sense? Is everyone good on that? Do we know t? This is really abstract, I know. This is good stuff. This is like college level stuff. We do not know what t is. And we're just going to say it's in the first quadrant, okay? Just for visual purposes. Make it 30, make it whatever, okay? In fact, we could even do that. We can make it 30 degrees. If I did pi minus t, where would we be at now? We take 180 and subtract 30 to get me to 150, right? So it'd be somewhere in here, okay? So this represents pi minus t, or 180 minus t. Okay, so question. This right here is equal to what? What was sine of t of this? What was given to us?
3/2.
True, absolutely. But in the context of this, right? We're saying this is not on the unit circle. They gave us the fact that it was 4/5, okay? So what I want you to do is just put 4/5 here. Okay? Now, sine is positive here. What would it be over here? Remember down here, right? All short teachers care, right? All right, so we know that at that point, this would be what? Positive as well. So if it's positive here, it would also be positive here. Therefore, what's the answer? 4/5. Stays the same. Stays the same. Okay? Again, do we know what t is? No. Do we have to know what t is? The answer is no based on what they gave us. I'm using an example and a visual so that you can visualize and see where we're headed. But if I take pi and subtract t, we stay in the second, and then we know that sine would be positive in the first and the second, okay? All right, how are you feeling right now? Let's do, makes a little bit? All right, so Annie, let's see if we can try this, okay? So the b part is t plus pi, right? We're going to start with t. Whenever they say t, when I draw it, because I have to draw it even as a teacher, I always talk about the first quadrant. And I just draw an angle and I just label it t. If I took t and then added pi, where would I be at?
In the third.
Third, right? Is everyone good on that? So I would have something that looked down like this down here. Because this would be t plus pi, right? So question, what's my answer, Annie, and why?
The sign would be negative.
Perfect. Good. Sine's negative because down here, tangent's the only one positive, right? So what would be my answer? If sine's negative down here, what would it be? I heard it. Negative 4/5.
Oh, okay.
The value doesn't change when we add pi. It doesn't change. Does the sign change? Yes, it does, right? Does that make sense? Cool. Bianca.
How would you get to the fourth quadrant?
How did I?
Like, how would you, if you, would you still add pi again?
I don't know of an illustration that would get us to the fourth. You're right. I'm not saying we won't, right? What I would say is just whatever they do, like right here. I draw a t, I add pi, and even if I have to draw it, like I'll draw it, and then say, okay, based on this, would it be positive or negative here? Would it be positive or negative here? And being able to kind of compare that. Does that make sense? So I would just draw that out rather than saying, oh, it has to be in the fourth. I mean, I don't know one that would be in the fourth, to be honest. That's a great question. Cool. All right, let's look at, let's do this one real quick. In fact, let me see. I think I've got one. I want to see if we can try these out. You see on your homework? Let's just try one out. Here's what I want you to do. In fact, could I do one of these together with you real quick? Because I did not hit on this one. Could I hit this one real quick here? Let's do that one. Make sure that we get that one, and then I'm going to have you keep going on a couple of these here. All right, so let's see what we've got. Someone talk me through cosine of negative t is negative 1/5. All right, someone help me with that. What would that describe?
Wouldn't it like not be in the first quadrant because it's negative? And it could, if it were in the first quadrant, it would have to be positive.
Yep, so we know that this is positive t, right? We still start with that. We remember that negative t, right? This would be negative t degrees. And that equals what for our cosine?
Negative 1/5.
Yep, this is negative 1/5. So that's the value down there. So now let's look at this, okay? What is cosine of t? Well, where's the positive version? Where's the positive version at? The first quadrant, good. And we remember that the first quadrant would be what? This is where it gets a little tricky. Okay, let me make sure of this. Let me make sure on this, okay? As we look at this, remember, all short teachers care, right?
Isn't it cosine positive in the fourth quadrant though?
Correct. This is a little different, okay? They're giving us the value. You follow me? They're giving us the value. Where are the cosines linked? That's all I care about. Where are the signs linked together? What quadrants? First and fourth, right? And really, if I'm honest, these two as well, right? They're the same as well. So if this one is negative 1/5, we could expect, right, that what's going to be the same up here? It's negative 1/5. Do you see that? Annie's right. The confusion comes when we say, well, I thought the fourth quadrant was the positive version, right? Here's the question. Remember, this is an example, right? This is an example. Do we know t? We don't know t, right? So you can't assume that we know t. I'm using this as a visual. So all I need you to know is that it's the same sign in the first and fourth and the second and third, okay? T could be anything. All we're saying is that the value is negative 1/5. We remember that cosine of t and cosine of negative t are the exact same. Now, if you don't get that, watch this. What was the definition that we already were given? Cosine of t is equal to cosine of negative t. Didn't we say that? Didn't we already prove that? Right? What was given to us again? Negative 1/5 was cosine of negative t, right? So what is cosine of t equal to? You see that? I used the definition. You see that there, Katie? So we would say that that's the definition. We plug in what we know, and we get cosine of t equals negative 1/5. Cool? So I'm showing you the visual, so you see it. You can also use the definition to get there as well. Okay? Cool? How are we feeling? Better? Okay. It's tough. It's a little tough, a little abstract. What about secant of negative t? What would that be? Exactly, which would be what? Negative 5. Good. Because the sign will stay the same when we flip it, right? If you find cosine of negative t, secant of negative t would be the same sign, just the reciprocal of that. Okay? All right? Questions? Cool. I feel like we need a little practice, just a little bit. So here's what I want. Just with someone next to you or just even by yourself as you try this, try to attack the second and third one. Okay, hold up. Did we do this one already? I think we did. I think we just did that. So let's do the second and fourth one. Those two right there are ones that if you get those two, we're headed in the right direction there. Okay, so if you could try those two, and then we'll kind of come together, make sure we're good, and then keep going. Cool. All right, go ahead. Do it. Freeze this real fast. While you're doing that, I'm going to get one of these things on the podcast that I forgot to get. If you're watching this at home real fast, I wanted to make sure, I did this flip chart over here on this side. I want to make sure you kind of get down. You heard me. I want to make sure you got it. So all short teachers care. What we're saying is that if we have cosine of t, that equals cosine of negative t, right? So if t was over on this side, and we say that that's positive t degrees, if we recognize that it's equal, I wanted to show you that if I had negative t would be the same thing except I'd go backwards, right? This would be negative t degrees. So it would be the same thing. We'd still get the same value here and here. And the question is whether it's positive or negative. Well, in the first quadrant, we don't know what t is, but we see that the first quadrant would be positive, and since it's cosine, this fourth quadrant will be positive too. So what we're saying is that these two are the same, okay? And you'll notice that really, actually, these two are the same as well, where it's negative. The one thing to be careful of that we hit into is the fact that cosine of t equals cosine of negative t. We don't know what t is, so you can't assume, like on the previous example, that you know it. But I used the first and fourth just as a visual, so you can kind of see that in fact this would be positive where cosine is positive too. So trying to identify that. So just a heads up on that. If you go back to the definitions over here, you'll recognize the even function. This is like where they're the same, right? And the odd functions have a symmetry where one they're the same except one's got to be negative. That's there, and you'll see that because if you go to if you did the same thing, right? Sine of t equals sine of negative t, that wouldn't work because if I did the same thing, sine is positive up here, but it's actually negative down here. So what we've got to do is cancel that out and say sine of t is equal to negative sine of negative t. And the tangent would be the same one there. And we would call that odd, an odd function, odd symmetry. Okay? Just want to make sure you got that down because it was on our flip chart. It's in class in here. You can come by and take a picture, but I want to make sure you got that as well. Cool, cool, cool. These are off your homework. These are good practices you got to do.
No, I'm writing down everything else on a piece of paper. Wait to tell me why I'm
Pretty good.
wrong.
Did you do these bottom ones here? What'd you get for A?
That's the one that we did on
We already did this one. Did we already do both of these two?
We haven't done that.
the. No, we just said sine of.
Is that what it was? I didn't do this one yet? Okay, perfect. I just want to make sure you got one rep on that one.
I thought we did that one on the board.
I have.
We did sine of t, not cosine of t. We did like the sine of 4 and 5.
Would it be the same? Or like just different?
I would draw t out in the first quadrant, and then remember it's pi minus t, right? So whatever t is, if it's 30 degrees or whatever. And the first one would be the first quadrant. Where would this one be? What quadrant would that be? The second. And do they have the same sign in the first and the second with cosine? No. You see that? So because it's not, what would be the answer for A?
When it's plus, it goes into the third quadrant. Only
Negative 4/5. The value stays the same, right? The difference is now you just got to include that negative there. Cool. You'll have a question. Yeah. So sine of negative t, right? Do we know what what t is? No, right? All I'm wanting, the reason why I show this is just so that you kind of get a visual where it's at. If I just say, okay, this represents t, okay? Perfect. Sine of negative t would mean the negative of the t means that it would go where? Instead of going up, it would go. It'd go to the fourth, right? Does that make sense? That's good, Audrey. So this would go down here on this side. Now, this would be negative t degrees, right? Now, once I get there, then I can identify, okay, on the first quadrant, the sine of t, that's 1/3, right? And I like to put this up here. This is 1/3. This is related with sine of t. Perfect. Okay. When I go downward, would sine be positive or negative down here? Negative. Good. So that's how we would say it's negative 1/3. Cool. Yeah. And it also goes with our definition too, right? Because we already identified that, okay, sine of t is equal to sine of negative t, right? Sine of t was 1/3, isn't that right? Isn't that what it said? So this is 1/3. I'm just plugging it in. So 1/3 equals negative sine of negative t. How do I get that negative on the outside out of there? I can get rid of it, but as long as I put a negative to the other side, right? It's like you're dividing by -1. And that's how I get negative 1/3 on that as well. Cool. Yes, nicely done. Good, good, good. The same thing, exactly. Once I find sine of negative t, just reciprocal of that. If that was cosecant of t, what would cosecant of t be? Positive t. What would that be? Exactly. Good, good, good. You got it. How is this feeling? Is it better than what you thought? At first you felt like this is crazy. Why we learn it?
So pi is right.
We're just looking, it's more like abstract math, so it's more like theoretical about why things exist. Why is all short teachers care really that way? And so understanding that if I take an angle and I add pi to it, right, no matter what that angle is, it has a relationship with what was originally the value of sine of t equals 4/5. So seeing how that operates. Also the symmetry. So if I looked at, this might be deeper than what you want. Do you remember the graphs of sine? Sine will look like this, right? And actually move this way, right? It's symmetric over the x and the y, right? So when it's symmetric over the x and y, we call that odd, which is what we talked about with that definition, right? Well, when we talk, so this is odd, right? When we talk about cosine is over top of the y value, right? So it's symmetric over the y axis. We call that even. So when it's even, it's symmetric over the y, whereas odd is symmetric over, we call it origin, like the x and y. And so these are linked to the definitions.
It's cosecant, so it flips x and y.
All right, thoughts there? Are we good?
And it's negative as well.
9:08. Okay, we got about 7 minutes left.
Right.
All right, boom, boom, boom. Okay, we hit on that. Okay. All right, hopefully you like my goat picture. I don't know why I put that. Sometimes my mind goes craziness. I don't know why I took a selfie with a goat. Funny story, it was at the church nativity. We had a church nativity, and I had a bright idea of getting a selfie with a goat. I was like,
My dad
Good.
almost bought us a goat.
really?
Just because he just wanted one.
Just wanted a goat?
Yes.
We should get a pet goat for GAC.
Honestly,
Senior prank. No, don't. No, Lord, please forgive me.
The elementary almost got goats,
Really?
and then they bought a ton of rocks instead. Apparently.
Rocks instead?
Yeah.
I could see the similarity.
Kelly about all of
That's awesome.
my dad wanted to get fainting goats for our camp so we could scare the kids.
Fainting goats. Have y'all seen fainting goats?
They're really funny.
They're the cutest things ever. Except I would mess with them. I would just make them faint all the
He
time.
just wanted to scare the
I'd just be going, bah, and just have them. Anyway, that was really weird. Conversation, that's my fault. Goats, everybody. Related to math, how? Coterminal. No, I don't know. All right, cosine of 7 pi. Yeah, I would tell you this. We talked over this, didn't we? Didn't we already do this? 7 pi we can't find on the unit circle. So what do I do with 7 pi?
Subtract.
Subtract what there, Hannah? You're right.
Pi. Or 2 pi.
2 pi, right? So we remember that that was smooth. I'm sorry. We subtract 2 pi, and we might have to do it a couple times to get to where we need to go. Okay? So just hold on to that. Negative 19 pi over 6 is a little tougher. What would you do in order to get it to an angle that we would know? Perfect. Maybe, and what would we do to find that coterminal, Caitlin? Good. I like that. So we take negative 19 pi over 6, add 12 pi over 6. Can everyone see why we got 12 pi over 6? It's like reduces 2 pi. And then I just keep adding until I get something here. I will tell you this, things like that are what the quiz will be over. You'll need to know that. Along with the unit circle, those are huge concepts. But I think we've been practicing that, right? We did that on Friday. Is there anyone, just so I know, anybody that's hard for them? That's a little tough? Okay? All right, good. If you have questions on that, come and see me before the quiz on block day, okay? Hey, last thing is this. Y'all know how to put these in your calculator, cotangent of 4.7 and stuff? Yeah? Could I do one with you real quick, just so we know? This is, I know, piece of cake easy, but I'm going to have that come up. What mode are you in on this one? Radians. That's tough. If I said cotangent of 180, different, right? We're talking in degrees. If I input degrees, I want degrees. If I input radians, I want radians, okay? So just as a heads up on that, that's something you just want to make sure you're keen in on, okay? All right, we're going to pull this up here. We're going to get out of here. And I just want to make sure we're good. Now, cotangent, is there a cotangent button? Make sure I'm in radians. Yeah, do not. Got me? I will haunt you. I will literally come to your house and I will haunt you. Okay? If you do this. All right? Not really, but I might. When I do this, do not do that right there. That's not cotangent. Got me? That's finding the angle. We'll talk about that later. To find cotangent, cotangent's the reciprocal of tangent, right? Right? Did you hear that? So I'm just going to do 1 divided by, parentheses, tangent of 4.7. Did you see that? 1 divided by tangent is my cotangent, all right? And again, make sure you're in radians when you do that because you're putting in radians. And when you get